In this lecture we will check the sample line selection guide for one of the most important manufacturers of sample lines for analyzer systems, the O'Brien Tube Selection Guide. The first type of material is commercial 316L seamless stainless steel. This is generally used for standard instrument tubing. Free iron molecules will react with most acids. The average surface roughness for this material is 80 microinch or above. It is limited by chemical reactivity and oxygen levels. Also, it is subject to stress corrosion cracking, and its high surface roughness values of its internal surface contribute to adsorption and desorption problems. Its advantages is that it is inexpensive and readily available. The second material is fluoropolymer or Teflon. This is generally used for low-pressure sample and chemical lines where 316L stainless steel is not acceptable. It is used for applications requiring cleanliness. It is limited by chemical reactivity and oxygen levels. Temperature and pressure limits vary by variety of fluoropolymer. Also, it is very permeable. Its advantages are excellent chemical resistance and its flexibility. TrueTube CP is an O'Brien TrueTube product. It is a chemically polished and clean 316L seamless stainless steel. It is limited by chemical reactivity and oxygen levels. Also, it is subject to stress corrosion cracking. Its advantages are improved surface finish and cleanliness, also, and most importantly, the free iron molecules contaminants eliminated. The TrueTube FS is also an O'Brien TrueTube product where a secondary Silconert 2000 coating applied to chemically polished 316L stainless steel tubing. It is limited by very poor resistance to bases. Reacts adversely with fluorides. Its advantages are improved chemical resistance over substrate alone. Can be used at higher temperatures than polymer coatings. Covalently bonded matrix, which reduces surface tension. Has found wide acceptance for transporting sulfur samples. TrueTube HCR is used for basic and highly acidic sample systems where corrosion is a prime concern. A secondary Durson coating applied to chemically polished 316L stainless steel tubing. Limitations are the adsorption and desorption sensitivity at part per billion and very low part per million concentrations. Its advantages are that it have the most corrosion-resistant coating. Acid and base exposure pH 0 to 14. 2 times more wear resistant than bare 316 stainless steel. TrueTube EP. This is used at critical sample systems where adsorption and desorption is a problem. Electropolished and chemically treated 316 stainless steel seamless tubing. Maximum surface roughness is 10 microinch. Limited by chemical reactivity and oxygen levels. Its advantages is that the chromium-iron ratio better than 1.5 to 1 and chromium oxide-iron oxide ratio better than 3 to 1. This lead to improved chemical resistance, improved adsorption and desorption characteristics compared to commercial tubing. The last tube is the TrueTube EPS. This is used for critical sample measurements in the low part per million and part per billion range. Critical sample systems where adsorption and desorption and moderate corrosion is a problem. A secondary Silconert 2000 coating applied to electropolished and chemically treated 316 stainless steel seamless tubing. Its advantages are that the O'Brien electropolished surface of this tube is the ideal substrate for Silcotech coating. Silconert 2000 covalently bonded elemental silicon matrix reduces surface tension and adsorption and desorption of moisture and sulfur species. Wide acceptance for transporting sulfur samples in part per billion range. Fastest response rate of any TrueTube product. Here we can check in this bar graphs the preferred type of material and coating for different components of interest for measurement such as sulfur, moisture, ammonia and mercury in samples with high acids and pH levels. Notice that when lower detection level is needed, we have to change and upgrade the level of coating and surface treatment. Here we see the different percentage of recovery of hydrogen sulfide sample with different tube materials and treatment. Notice that for commercial stainless steel tube and after 4 days only less than 5% of the sample is recovered. While in the electropolished and coated tube 100% of the sample is recovered.